This video is going to go over acceleration. Most objects do not travel at a constant velocity. If you look at the graphics on the right, the top graphic shows a car that was sitting at a traffic light when it was red. When the light turned green, the car had to increase its velocity in a forward direction until it reached its full speed. Because it was at a stop and then increased its speed until it reached full speed, we call that speeding up or positive acceleration. In the second part of the graphic, it shows a car approaching a traffic light that has turned red. The car, at a faster speed, has to slow down and come to a full stop. That is negative acceleration. Remember that a velocity can either be a change in speed or direction. So from the merry-go-round example from the previous video, as the people riding the merry-go-round move in the circular motion, even though they're at a constant speed, they are changing their directions all the time. Thus, those people riding the merry-go-round are accelerating, and each of them are trying to move in a straight direction. However, they are attached to the merry-go-round, so they continue to move in a circular motion. So let's take a look at how acceleration looks in a mathematical form. We calculate acceleration using the equation a for acceleration equals the change of velocity over time. The change of velocity is the final velocity minus the initial velocity to find the change. And that is all divided by the amount of time that it takes to make that change in speed. When you do this, you end up with the units meters per second, or meters per second squared. This will become more clear as we go through an example. A jet airliner is at rest on a runway. At takeoff, it reaches a velocity of 80 meters per second straight down the runway in 20 seconds. What is the jet's acceleration? Note on the right graphic the graph showing positive acceleration. The speed over time increases. Thus, the plane is getting faster and faster as it goes down the runway. Let's solve for its acceleration. The first thing we should do is write down all the variables. A is acceleration. We don't know that. That's what we must solve. Vf is the final velocity. The velocity of the jet airliner, once it reaches full speed, is 80 meters per second. The initial velocity is 0 because it was at rest or not moving on the runway. And t for time is 20 seconds. So essentially, we're trying to find out what was this plane's acceleration, because it went from 0 to 80 meters per second in 20 seconds. So we apply our equation. A for acceleration is equal to the velocity final minus the velocity initial over time. We plug in our values. The initial velocity was 0 meters per second. The final velocity was 80 meters per second. The time was 20 seconds. We end up with 80 in the numerator and 20 in the denominator. $80 divided by 20 is 4. And our units would be meters per second, or 4 meters per second squared. And it's a positive acceleration. We can either leave it as a positive number or put the plus sign in front of it to emphasize that it's a positive acceleration. So that answers the question of how much acceleration this object was occurring as it got to full speed. 4 meters per second squared. Let's look at another example. A skateboarder is moving at a constant speed of 3 meters per second in a straight path and comes to a complete stop in 2 seconds. What is the skateboarder's acceleration? Note in the graphic that the skateboarder has a negative acceleration where speed over time is much slower over time until it reaches a complete stop. Again, let's identify all the variables. Acceleration, we do not know. The final velocity, it was coming to a stop, so it's 0 meters per second. The velocity initial was 3 meters per second. And the time it took to stop was 2 seconds. We use our equation. A for acceleration is equal to the final velocity minus the initial velocity over time. Plug in our values. The final velocity was 0 meters per second because it was at a stop. And then the initial velocity, when we first started recording, was 3 meters per second. It took 2 seconds to change the speed. 2 in our denominator, and it'll be a negative 3 in our numerator. So we end up with a negative 3 over 2 meters per second per second. What we end up with is a negative 1.5 meters per second squared. That would be the acceleration of the skateboarder. It's negative because it's coming to a stop. It's slowing down and stopping.